Today's lesson is 15-4, which is measures of center. Now, measures of center are mean, median, and mode. The first thing we want you to do is watch the video in Khan called Statistics Intro, and it's on mean, median, and mode. Then when you finish watching the video, I want you to make sure you write down the vocabulary listed here. So measures of center, that's what, as a group, that's what they're all called. Measures of center are numbers used to describe the center of the numerical data set. One of those measures is called the mean, okay? The mean, or the average, of a set of data is the sum of the data divided by the number of data values. So you just add them all up and divide by how many there are. Another measure of center used to describe the numerical data is the median. The median is the set of the data set is the middle value when the data are in order from least to greatest. Now, there are two requirements here, okay? Now, if there is an odd number of data values, so that means if you have 5 numbers, for example, the median is the middle data value, okay? Now, this is where you have to do some calculations if there is an even number of data values. If there's an even number of data values, the median is the mean of the 2 values in the middle. So that means the 2 values in the middle, you just add them together and divide by 2. So just as the mean is a single value used to summarize the data set, the median also summarizes the data with one value, okay? A third measure that can be used to describe the center of the data is the mode. The mode is the data value that, or values that occur the most often. The mode is the data value or values that occur the most often. The mode shows the popular choice, or the choice that was chosen most often by the sample. Now, remember, the mode, see it says here value or values. So that means you can either have just one mode or you can have more than one. So for example 1A, we want to find the mean. So here the table shows the number of headphones sold at an electric store during a sale. We want to find and interpret the mean of the data. Okay, and again, the mean is the average. And the way we're going to find it is we're going to take the sum of the data and divide by the number of data items. So make sure you write down this formula. The mean is the sum of the data divided by the number of data items. Okay? So the first thing we want to do is we want to add up all of this data. And yes, you are allowed to use your calculator. All right. So we've got 9 plus 18 plus 2 7s, that's 14, plus 10 and 15, that's 25. So plus 25, and that gives us 66. So we write 66 divided by how many there are. That's 6. 1, 2, 3, 4, 5, 6. And then we just do that division, so we know that's going to be 11. So the average number of headphones sold at an electronics store during a sale is 11 headphones. Make sure you label. Okay? So press pause on the video, try example B on your own, and then press play again so you can see the solution. It says, Coleman and his friends are comparing the number of apps purchased over the past month. They purchased this many apps last month. Find and interpret the mean of the data. So go ahead and press pause and then play to see your solution. So again, the mean is the sum of the data divided by the number of items. So here when we add 3 plus 0 plus 4 plus 2 plus 6, we get 15. And we are dividing by 1, 2, 3, 4, 5 numbers. Remember, when you have a 0 in there, that still counts as a data item. Okay? So we're going to divide by 5, and we end up with 3 apps. So Coleman and his friends, on average, purchased 3 apps last month. All right, so example 2a is find the missing data value using the mean. So it says the table shows the greatest depths of 4 of Earth's 5 oceans. If the average greatest depth is 8.094 kilometers, what is the greatest depth of the Southern Ocean? And we want to round, if we need to the nearest hundredth. So what we're looking for is this down here. So again, our formula is the sum of the data divided by the number of data items. So this is my formula. Okay, here's my formula. Now we can substitute in. Now, when we get the sum of the data, well, actually, we know something up here. We know that the average greatest depth is 8.094 kilometers. That is the mean. That's the average. That's the mean. That goes here. Okay, so we're going to put in the formula when we substitute 8.094. That equals to the sum of the data. So here we want to add all of this up, including this one that we don't know. Okay, so we're going to use our calculator, and we're just going to add these all up. So we have 10.92 plus 9.22 plus 7.46 plus 5.63 plus this one that we don't know. And of course, if we don't know what it is, we're going to just put plus D. Okay? So we're going to write 33.23. That's all of those. So 33.23 plus D. That's the one we don't know here. And then we're going to divide by the number of data items. Well, how many are we going to divide by? We're going to divide by all 1, 2, 3, 4, 5. We want to include that D. So we're going to divide by 5. Because we are including that in the sum of the data. Okay? So now we just have a multi-step equation that we need to solve using our inverse operations. So remember, when we're using solving using inverse operations, we want to use our cover-up. So we're going to cover up this part up here, because that's what we're solving for. We've got that D up there. And what do we need to get rid of? We want to get rid of the 5. Now, because this says all of this blue stuff divided by 5, how are we going to get rid of that 5? We're going to multiply. And we're going to multiply on both sides. So we multiply times 5 on this side, and we multiply times 5 on this side. So here, those 5s, this one and this one, they cancel to 1. And then we're going to simplify by multiplying 8.094 times 5. that gives us 40.47. So this is 40.47 is equal to, now this is equal to, those simplified to ones, right? So those canceled out. So we're left with 33.23 plus D. And now it's just a one-step equation. So I'm going to cover up my D, including its sign. And what do I want to get rid of? I want to get rid of the 33.23. Now, because this is a positive 33.23, how am I going to get rid of it? Good. We're going to subtract. So we are going to subtract 33.23 on both sides. Because remember, you want to show your inverse operations and you want to show that you're keeping the balance. So here, these cancel to 0 now because anything minus itself, that's 0. And we're left with D. So we've got D on this side, and then we just subtract over here. So we've got 40.47 minus 33.23, and that gives us 7.24. So 7.24, and my label, of course, is kilometers. So D, or the depth of the Southern Ocean, is 7.24 kilometers. So now I would like for you to try example 2B on your own. So please just pause the video, do the work in your notebook, and then press play to check the solution. All right, so it says 7 members of the community group sold an average of 45 boxes of cookies. The 6 members sold this many boxes of cookies. How many boxes of cookies did the other group member sell? So we want to know how many did the 7th community member sell, okay? So again, we start with the formula. And then we will substitute what we know. So what we did here is we added up this 255 is these 6 members. Okay, those are the boxes that the 6 members. We also want to include that 7th member, so this X is the 7th member. And then when we divide by all of the items, that's all of the 6 plus that 7, so that's the reason why we're dividing by 7. So using our inverse operations, we multiply by 7 on both sides, and we get 315 is equal to 255 plus X. So now, because this 255 is positive, we're going to subtract 255 on both sides, and X is equal to 60 boxes. So the 7th community member sold 60 boxes of cookies. Example 3A is to find the median given an odd number of data values. So it says, Dinah's scores on a recent science test were as follows. We want to find and interpret the median of her test scores. Now remember, the median means that is the middle number. Okay? The median is the middle number when the data is in order from least to greatest. So the first thing we need to do is make sure that our data is in order from least to greatest. All right, here's our data in order from least to greatest. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. So that means because it's an odd number, we're only going to have one middle number. Okay? So to get to that middle number, you can just cross things out here like this. Pink, pink. Pink, pink. Pink, pink. and think, think. So now your middle number is 89, so your median is 89. And that's it. Equal to 89. Okay? 89 points on the test. Okay? So the median number or the middle value would be 89 points on this test. Now, I do want to tell you that since there's 9, let me just tell you another shortcut on how to get to the middle number. Because what if you had like a larger than 9 and you didn't want to, if you did not want to just go ding, 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 and cross things out like that. Okay? So you can just divide by 2. So to get to the middle of something, you just split it in half, right? So if you have an odd number, if you divide that by 9, divide 9 by 2, split it in half, you get 4. But when we finish this, we have 1 left over. That 1 left over is going to be your middle number. So here, you could take 9 divided by 2 is 4, so that's 1, 2, oops, no, I'm sorry. So that's 1, 2, 3, 4. But then, to get to the middle number, you just add 1 more, okay? So this, the 5th number, is going to be your middle number. So press pause and do example 3B on your own. And here, this again is find the median of an odd number of data items. So here, you just put the data in order from least to greatest. Oh, I didn't even read the problem. It says the number of the stories in tall buildings in a certain city are as follows. Find and interpret the median height of the buildings. So again, the median is the middle number when the data is in order from least to greatest. So we need to put the data in order from least to greatest, and then you can find the middle number. You could also use that shortcut of dividing by 2 and adding 1. So that's how we get to our 5th number here in the middle, and that median is 21 stories. So what if you had an even number of data values? Okay, so this is example 4A. Find the median given an even number of data values. So here the table shows the prices of different packages of juice boxes at a local store. We want to find and interpret the median of the data. So the first thing again you want to do is put the data in order. From least to greatest. So the first thing we want to do is put this in order from least to greatest. Now I'm going to write them going up and down this time. So 197, then oops. Okay, so here's my data in order from least to greatest. Let me double check. So here, you guys, there are 8 numbers. So when there's 8 numbers in a set of data, to get to the median, we have to find the 2 middle numbers. So let's see, 8, and I'm just going to, 8 divided by 2 is equal to 4. So I'm going to split it in half, right? So that means 1, 2, 3, 4. And then from the bottom, 1, 2, 3, 4. So here are my 2 middle numbers. Okay? So to find the median, we want to add those 2 numbers together and then divide by 2. So you're going to add the two middle numbers, and then divide by 2. Okay, so you can just as a reminder, you can write that down. So we're going to add 2.45 plus 2.49, and then we will divide that by 2. And of course, you are allowed to use your calculator. So that gives us 4.94. We're going to divide by 2. So our median is 2.47. 2.47. And this is the cost of juice boxes. So this is money. This is $2.47 is the median price. So for example, for B, I want you to press pause and do this example on your own and then play to see the solution. So for example, 4B says find the median given an even number of data values. Okay. Tara spent this much money on school lunches over the last 8 months. Find and interpret the median of the data. So again, for the median, we're going to put the numbers in order from least to greatest. Then I'm going to find the two middle numbers, because this is an even set of data items. So that's 1, 2, 3, 4 from the front, and 1, 2, 3, 4 from the back. So that 46 and 50 are my two middle numbers. We add those together and divide by 2, and that gives us our median dollar amount for how much you spent, the median value on lunches. Example 5 is to find and interpret the mode. Now remember, the mode is the number that occurs the most often. Occurs the most often. Number or numbers. So you can look at this data here. This is a table shows the number of miles Jonah ran every day for a month. Find and interpret the mode of the data. So here, you guys, you can look at the data like this and then just try to count. How many times does it happen? Each of these numbers happen. Now, I'm going to tell you that the better way to do this is to go ahead and put the data in order from least to greatest. Organize it. Organize the data. And then once you have your data organized, then you can see which numbers occur the most often. Okay? So let's start with putting these in order. So let's do, and we'll cross them off as we go. So the lowest number is 1, right? So there's 1, 2, 3. So we've got 1. So I'm just going to do like that. So 3 ones like that. Now we've got 2s. So we've got 1, 2, 3, 4, 5. So that's 1, 2, 3, 4, 5. The next highest is 2.5, right? You see 2.5 in there? Yep, 2.5. So we've got 1, 2, 3, 4. So there's 4 2.5s. So 1, 2.5, oops, 2.5. You guys see what I did? 2.5, 2.5, 2.5. So I missed one, didn't I? So I missed 1.5. You see that? So I'm going to have to move this over. You can just erase the first one. So we're going to put those 1.5s in here. I missed it. So go back and do those 1.5s. So there's 1, 2, 3 of them. So 1.5, 1.5, 4.5. Okay, so I think that's good so far. Now so we're at 2.5. So now we've got 3. So there's 1, 2, 3, 4. So there's 1, 2, 3, 4. There's 4 threes. Then we've got a 3.5. 3.5. Let's see. There's 1, 2, and 3. So there's 3.5, 3.5, and 3.5. Okay? And then we've got a 4. So now we're on 4. So it's 1, 2, 3, 4. There's 4 of them. 4, 4, 4, 4. And then we've got 4.5. There's 4.5 and there's 4.5. Are you seeing what I'm seeing? 4.5, 4.5, and then we've got a 5. Now, this must be a typo. I'm going to have to check this out before I put this in here. Okay, that says 43 miles. You think he ran 43 miles in one day? Okay, I checked it out, and it does say 43 in the book. So, even still, if we put 43 in here, that's kind of crazy. I don't think that Jonah ran 43 miles in one day. That's nuts. But I'm going to put it in there anyways, okay? So just because that's what the data says. And again, people who are writing this, putting this data in here, maybe they meant to put 4.5. Maybe they meant to put 4.3. Who knows? But I'm just going to put 43 because there's no decimal in there, okay? So we want to look to see what the mode is. And, you know, this is not a big deal because that 4.3 doesn't affect the mode. What's the number that occurs the most often in this list of data? 2. So the mode is 2. The mode is 2 miles. That means that during that month, whatever that month was, he ran 2 miles on any certain day, on a certain whatever given day, 2 miles more times than any of the other amounts. All right, so I want you to press pause and do example 5B on your own. Find and interpret the mode. So it says the table shows the daily high temperature for 2 weeks in a given city. Find and interpret the mode of the data. So here, when we put the data in order, okay, we've stacked them up like this, you can see the highest stack is 82 degrees Fahrenheit. So that means for 2 weeks, they had more 82-degree temperatures than any of the other temperatures. Now I'm going to go back to example 5A real quick, and I just want to mention, remember we said you could have more than one mode if the situation arises. So let's say that we only had 4 2s in here, okay? So that means that the highest number here, okay, we've got a 2, we've got, let me change the colors, we've got a 2.5, that also has 4, we've got a 3, and we have over here a column 4 has 4. So if if this is what the data looked like, okay, if this is what the data looked like, then in this case there would be 1, 2, 3, 4 modes. Okay, so in this case, the mode, and this is an alternate problem for example 5a, the mode would be equal to 2, 2.5, 3, and 4. Okay, so this is an example of when you would have more than one mode. And I will attach that example to the end of the written notes. Oh, or maybe I'll just put it down here. So I'm going to put that example that we just did, I put it down here as the extra 5a example. Okay? And I'm going to call it alternate 5a example.